Well, soccer or football is one of the most professionally big league games, and no doubt the players as well as its fans go crazy during the matches. Interestingly, there's a whole bunch of mathematical operations and algorithms behind it. I call it soccer mathematics. Starting with the basics, there are two teams, each consisting of 11 players, that aim to score the most goals in 90 minutes on the field, having specific dimensions which are in relation to geometry. There's match going on in time management of the game too. To investigate the maths behind soccer, we use geometry expressions, which is a constraint-based geometry system, and Maple, a computer algebra system to model situations that take place during an average soccer game. Most of the game is geometry of the game is necessary. For example, Barcelona's team of 2010 to 2011 created the most beautiful one ever seen on a soccer pitch. This gives us a higher chance to enhance the ability to score a goal, stop a goal, and maintain possession of the ball. The most familiar spherical polyhedron is the soccer ball. It is made up of 12 black pentagons and 20 white hexagons. This is an example of tessellation figure showing significance of geometry. The shape of a soccer ball is called truncated icosahedron. The idea of calculus is used remarkably in the game. The pressure to be applied while shooting, curves of the ball after shooting, side of the kicks, etc. are a part of it, and mathematics mean on the field. There's an integral member in the team's mathematician. There is so much mathematics in soccer that most teams have some form of mathematician who work for them and tries to work out how the team could play better. The real-time use of strategy called tiki-taka is used significantly in soccer games.
Randomness and last minute changes are the key features of a soccer match. The navigation of the teammates as well as the opponents is of major importance. The crucial role of each player within the team is following and interacting with each other. They tend to produce consensus decisions, and this is all done in terms of probability, statistics, and vector field graph. The field in itself is full of numerical values. Each line that is marked is a representation of a certain distance, measurement, or shape. The concept of percentage and fractionalization of the enumeration is used regarding the decisions made in the game. Most players on the field follow a pattern in their penalty shots, and this analysis, which is maths in disguise, puts the keeper in a much better situation to predict the next shots. All these algorithms and the concepts we apply help the soccer teams to come down to be capable of making player forecasts, giving an edge in the game. Managers of soccer teams use passing networks to scout out opposition and find which connection are most used and try to break them down. The study of strategies and game theories, which is depicted by graphing and tabling, has shown constant changing evolution of football strategies. Wait, why to spare the audiences? Their counting and hospitality requires maths too. Counting their approximate number, buying the necessary items for their food, and their sitting arrangement all requires unitary method. Mathematics in soccer is about using it up in analogies between different parts of the game. It gives us the edge, the little bit extra understanding which helps us to win a few more matches than we lose, and that is why mathematics is important to soccer. Thank you.
Okay. Thanks a lot, Nandini. Thanks a lot. Just give me a moment, Ruhana. I'll be coming to you. We'll be having 1 minute time in which you can answer the question. But very well answered, very well debated, Nandini. I must appreciate, and I really like the audience point of view. That was really very nice, and the probability point of view. These two were really very nice. And for Ishan, I must say the point that you mentioned over there, that soccer field has mathematicians that they tell how they can make their match, they can make their play always better. So that was really very interesting points that you just said. A virtual clap for both of you as well. Now coming over to 1 minute, and Ruhana is very excited to ask a question. So over to you, Ruhana. You can start your 1 minute start now.
Well, obviously, all of us know that the force would obviously differ when the field is wet due to rain. But how much would the angles from which the footballer hits affect the force, or how the ball is sent across the field? Or what is the preferable angle that should be used in the following situation?
So, ma'am, may I answer?
Yes, please go ahead.
So the preferable angle is basically 45 to 55 degree, but it's said that the bigger the angle, the more goal the player taking the free kick would have to score. So basically, I think you might have got your answer, but we prefer 45 to 55-degree angle in such situations.
Wouldn't it be
Normally.
affected if the is wet? Because the friction
Yeah,
would
it would be
increase.
affected. It would be affected because the force to be applied will be more. So I think the angle will differ, but it all comes in terms of the mechanical strength put up by the footballer. So the angle differs with it.
Okay.